Today we are in section 8.1, Relations and Functions. You're going to notice pretty quickly that the concepts that we learn in chapter 8 are much different than any other concept that we've learned so far this year. For the most part, it's been pretty solid algebraic, working with variables, solving inequalities, solving equations, that type of thing. Now we're kind of shifting gears, and we're going to be working with relations, functions, linear equations, a lot of graphing this chapter. All right, so the first thing we want to start with is some definitions. All right, so I want you to go ahead and, honestly, you're going to write down most of what's in this paragraph. I would prefer you to bullet the different terms. Ordered pairs form a what? Ordered pairs form a relation. Okay, so you know what an ordered pair is, right? That's an x value and a y value put together. So they form a relation. A relation is a pairing of numbers in one set called the domain. All right, so you don't have to write down that. This is what I want you to write down about domain. Domain equals x values. Domain is your x values, also known as your input. So there's a couple different terms for x that you need to be familiar with. So if I say input, which value am I talking about? X. If I say domain, which value am I talking about? X. All right, then you're going to have your range. Oh, you can't really see that. All right, let me write it in black. All right, your range, well, if your domain's your x values, what's your range going to be? Your y values. Okay, or what we call your output. Okay, so again, your y values are going to have a couple different definitions too. So if I say output, which value am I talking about? Y. If I say range, which value am I talking about? Y. Okay? So I'm essentially still talking about an ordered pair, right? I just might call it domain and range. I might call it input output. I might call it XY, but it's the same thing. It's still an ordered pair. All right, go ahead and finish writing down those definitions. All right, so now let's move on to example 1. In example 1, I'm going to look at this set of numbers, okay? Now, I can pull these numbers in this table out and form ordered pairs because, look, they're x values and y values, okay? So I'm just going to match them up. 2 and 32 becomes my ordered pair 2, 32. Does that make sense? Yeah. All right, so I can pull the numbers out of the table to form ordered pairs. And that's what I did. So I want you to go ahead and write down those 5 sets of ordered pairs. All right, so in the past, what did you do with an ordered pair? What did you do with it? You plotted the point on a graph, right? Okay, so everybody have those ordered pairs written down? Okay, so guess what we're going to do? Well, before we do that, let's identify the domain and range. Now, on the first section of your homework tonight, this is basically what it's going to ask you to do, and we'll come back to that table in just a second. All right, so if I'm identifying the domain, I want to write in order, okay, I want to write them in order, least to greatest, my x values. So what are my x values going to be on this table? 1, 2, 3, 4, and 5. All right, and what's my range going to be? Very good. 47, 61, and 73. And it's as simple as that. So the first 4 problems on your homework tonight are just list out your domain and range. Okay? It probably would have been more helpful if we had done it on the ordered pairs that you just listed out. But we're going to hang on to those ordered pairs that y'all just wrote down because we're about to graph those. Okay, ready? All right, so identify domain and range. Anybody have any questions on how we got those numbers? Okay, so now let's talk about how we're going to represent a relation on a graph. All right, so I want to use those numbers. We're actually not going to use these numbers. I want to use the numbers from the first set of numbers that you just wrote down, the first set of ordered pair, the first, these, right? Actually, sorry. We are going to use, we will use these, but one of them is wrong, so I need to change it real quick. All right, this ordered pair is supposed to be -1, 1. All right, otherwise it's not going to fit on the graph. All right, so now what I want you to do, okay, we just said that what do we do with ordered pairs? We plot them on a graph, right? We plot the points. So the way that we represent a relation on a graph is we just plot the points. So go ahead and get out your graph paper. We'll set up a graph and we'll plot the points. All right, so when you're setting up a graph, this is just a reminder, but I know it's been a while. Remember to skip that first line, okay? Because what number does that stand for? That number stands for your 1, right? So you skip the first line because that's your 1, and you don't want to clutter up your graph with a bunch of numbers, so that's why we're skipping every other line. All right, 2, 4, 6, 8, and we assume that the lines in between are our odd numbers. -2, -4, -6, and -8. And then -2, -4, -6, and -8. And now we can take those ordered pairs, and I'll go back to that previous slide so you guys can get them, and we're just going to graph the ordered pairs on the graph, and that's how we would represent the relation on a graph. So our first ordered pair was -1, 1, so you plot it, and then I want you to label the ordered pair, -1, 1, okay, label it on the graph. Then our second one was 2, 0, so then we're going to label it 2, 0. Actually, we'll label it under here, 2, 0.
Wait, I thought it was up or down for some.
No. It's X first, then Y. Okay, so we go across and then we go up or down. Okay, so 2, 0. Then we went 3, 1. Then 3, 2. So those are real close to each other. All right, 3, 1. And we can kind of draw the arrow. And 3, 2. And that's this point right here. And then the last one was 4, 5, right? All right, so I'm going to plot that point at 4, 5, and I'm going to just label the ordered pair. And now I've represented the relation as a graph. That's it. That's all I had to do. Okay, so you're going to have 4 of these on your homework tonight where you're going to set up your graph, and you're just going to plot the points, plot the ordered pairs, and that's how you represent the relation as a graph. Now, the second way that you can represent a relation, we're going to use the same sets of ordered pairs, and the second way that you can represent a relation is through a mapping diagram. Now, with a mapping diagram, I'm going to list them as my input-output values, okay? And I'm just going to kind of make a chart. Actually, I don't need that line in between. My input and my output values, and I'm just going to list them in order. So I go from -1. Let me see. I give a -1, 2, 3, 3, 4, 5. Okay. -1, 2, 3, 4, 5. Now, 3 does repeat, but I only have to write it once in my mapping diagram. Okay? Now, for my outputs, I'm going to list them least to greatest. Okay, so what was my smallest output value?
1.
My smallest output value was 0 and then 1. All right, so 0, 1, 2, and 5. Did we cover them all? 0, 1, 2, and 5, because 1 was listed twice. All right, and yeah, we put the 5 in the wrong spot. Okay, so now we're ready. All right, so now we're just going to match up our ordered pairs. So our first ordered pair was -1 and what?
1.
And 1. So I'm going to draw a line from -1 to 1. with an arrow. That's it, okay? Then, what was my output for 2?
0.
0. So I draw an arrow to the 0. What was my output for 3?
1.
And what?
2.
2. And what was my output for 4?
5.
5. Okay, so, and that's my mapping diagram. That's how I would represent the relation as a mapping diagram. You're going to have 4 of these on your homework tonight, okay? The same 4. All right, so you'll take the same set of numbers and you'll graph it, and then you'll take that same set of numbers and you'll do a mapping diagram. All right, make sense? Okay, so that's relations. Now, with functions, a function looks just like a relation, except there's one rule with a function that's not a rule with a relation. And with a function, and you need to write this down, for each input, there's exactly how many outputs? 1 output. So each input can only have 1 output. You can't have an input of, let's say, 6 and an output of 10 and an output of 12 for the same input. That makes it not a function. Now with a relation, it's still a relation, okay? That doesn't have any rules. But with a function, each input has exactly 1 output. So the numbers you're about to look at, you're going to say, oh, well, that looks like a relation. It's because it is. But it doesn't mean that it's a function. Okay, so now we're going to look at these 2 sets of numbers. Now, this is kind of going back to the alligators example. So one of these sets of numbers I think you've already seen. But let's just look at them as far as their inputs and their outputs. The first thing we look at to determine whether or not a set of numbers is a function is their input value. So I have a 2, then what? What's my next input? 4, then what? 5, then 5, then 7. Here's my red flag. I have 2 ordered pairs that have the same input. Do you see that? Now my rule for a function is for every input there's exactly 1 output. Well here 5 and 65 are matched and 5 and 69. So 5 has 2 outputs, which makes this not a function. Not a function. All right, so the first red flag that we saw was that we had 2 inputs listed, and then there was a different output for each one of them, so it's not a function. Now let's look at the second one. Well, let's list our inputs. Our first one is 1, then what? 2, 3, 4, and 5. Okay, so it's a function. I automatically know because I don't have an input that repeats. So I know I have 1 output for every input and it's good. So yes, it's a function. Okay? All right, so for each input, there's exactly 1 output. That's the rule for the function. Now, moving on to example 4. Okay? Let's talk about the vertical line test. And this one, you're just going to be kind of watching the screen. You might want to rewatch the video so you can see this part if you want to see it again. I can tell whether or not a relation is a function by using the vertical line test. Okay? So I can just look at a graph. But we just did these, didn't we? Didn't we just graph a relation? So it's going to say, tell whether this relation is a function by using the vertical line test. And here's what it means. Take any one of the points on this graph, and if you can draw a vertical line through it, and it doesn't hit any other points, then you know that it's a function. And yes, it needs to apply to every point that's on the graph. Now, you don't have to do it 5 times, but you want to make sure, all right, that it doesn't hit any other points. All right? What do you think? Did I hit any other points when I drew a line through it? No, I didn't. So I would say yes, this one's a function because it passed the vertical line test. So yes. Now, let's look at one that would not be, so you can just see the difference. This one would not be, because look, in one vertical line, how many points lie on that vertical line? 2. So for that x value, for the x value of 3, I had 2 different outputs. I had an output of 1 and an output of -2. I can't have that. So no, it is not a function. Do you see the difference? Because when I put the vertical line through the points, it landed on more than one point. Fails vertical line test, not a function. All right, and that's everything you need to know for this section. So we're done with 8.1.